All right, good morning, you guys. I'm going to review your equations test review. I'm going to go over each question with you, and I will post this to Shobi for you to review prior to writing your test. Your test is going to look very similar to your review, with the addition of some problem-solving questions as well, which you've also had many to review. If you haven't checked out my videos on the one-step and two-step problem-solving questions, I encourage you to do so prior to the test so that hopefully that will answer any questions you have. Unfortunately, I was hoping to go over this with you guys through Zoom, but we are no longer allowed to use that platform. So we are looking at switching to Microsoft Teams. I will keep you guys in the loop as to what you need to do when that comes around. But for today, this is going to have to do for the test review. So your first section of your review is comparing equations and expressions. Now we've used both equations and expressions. We've discussed this previously in class, and we noted a few things that would help us determine which was an expression and which was an equation. When we were doing our expressions unit with patterns, we solved many one-step and two-step expressions, and those expressions, in order to solve them, required you to be told what the variable was. It did not have a total in the question, so there was no equal sign, there was no total, and you had to be told what the variable was in order to be able to solve. With equations, it is similar, but there are some differences to help you identify them. So number one, like I said, there's a total in an equation. And the reason you have a total is because it allows you to solve for the variable. So in an equation, you're not given the variable. You have to look at the total and find out what the variable is based on that information by using opposite operations to solve and getting the variable by itself. So in the instructions, it says which are expressions and which are equations. And they labeled expressions free as a bird and equations as locked in jail. That's just a term for you to hopefully remember that one needs an equal sign. It's got a total locked in on the other side to help you solve. That's an equation. And an expression doesn't have any equal sign locking them in. So that's where that term comes from. So based on that information, if we take a look at our questions we have, I'm hoping this board doesn't have too much glare and that you can see this. I'm using my daughter's easel. This seems to be a little bit better. You've got 4x subtract 9 equals 11. So if we take a look at our indicators as to whether it's an expression or equation, we can see that it has a total, okay? And this would be a question where you could solve and you could tell me what the amount of the variable was. So if that's the case, then that is an equation. And I'm just going to put EQ for equation, okay? The next one, we've got 15 plus 6x. There is no equal sign, and there is no total for this question. So in order to be able to solve this question, you would have to be given the variable, which makes it an expression. The next question, although it looks a little bit different, it does have an equal sign and it does have a total. So if it's got an equal sign and a total, you could solve for that variable by canceling out the other numbers that are on the same side with it. And if that's the case again, it's an equation. Oh, I missed one. I missed 8C. I'm sorry. I missed that one above it. Okay. 8C, again, no total. I would have to give you the value of the variable, which is C, to be able to solve for that. So that one would be an expression. Okay. And then you've got M divided by 5 equals 7. Again, you've got an equal sign and a total there. You could use that information to get the variable by itself to find out the total. So you could solve for the variable. That makes that an equation. And the last one here is 15 plus 5x subtract 9. Again, there is no equal sign there. So you would have to be given the variable, which makes that an expression. Okay, so those are the answers to your first 6 questions. 4x minus 9 equals 11 is an equation. 15 plus 6x is an expression. 8c is also an expression. Negative 24 equals x subtract 17. That is an equation. M divided by 5 equals 7 is also an equation. And the last one, 15 plus 5x subtract 9 is an expression. Again, the difference being if there's a total or an equal sign, you can solve for the variable. If not, with making an equation. If not, you would have to be told the value of a variable in order to be able to solve that, which would make it an expression. Okay. Question number 7 has the following. I just got to draw it real quick here. So this is your pictorial representation of an equation. Okay, it says which one of the following does the illustration represent? So first thing I'll do is draw the pictorial version. So remember, equations are like balancing a scale. They need to be equal on both sides to remain balanced. So we treat this triangle as the equal sign. Okay. We represent variables and whatever we're multiplying that variable by the number of large green blocks. So it looks something like this. You got 2 large green blocks on the one side of the equal sign. Then you've got 4 white tiles. Now, this is going to require a little bit of critical thinking on your part because these tiles don't have positives or negatives in them. And then on the other side, we have 12 red tiles. Okay, so that is the pictorial representation of the equation that is presented to you, and it's giving you 4 options. 4 options to choose from to pick the one that represents this fraction, or this, I keep saying fraction, this equation. Okay, so if we take a look, we know that we've got 12 red tiles over here, we know we've got 4 white tiles here, and we know we got 2 tiles that represent x. So first thing we're obviously going to know is that this 2 tiles that represent x represents 2x. Okay? Now if you take a look at A, B, C, and D, they all start with 2x. Okay? So we need to look at what else we have here. We've got an option of 2x plus 4 equals 12, 2x subtract 4 equals 12. 2x equals 12, and 2x subtract 4 equals 7. Well, right away when we look at those, we can cancel out the 2x equals 12 because we know we've got more than just 2x here. We've got 2x and then another 4 tiles. So we know we got either 4 positives or 4 negatives there. So we need to cancel out C. 2x equals 12 does not work. D is another one we can cancel out because it says 2x subtract 4 equals 7. But if we look at our total on this side, we've got a total of 12 blocks on that side. So 7 cannot be the total. So we're left with A and B. Now, using our critical thinking here, if we look at A and B, we realize that the answer for A and B both equal a positive 12, which tells us that red must be positive, which means white would be negative. Okay? So if we take a look at our answers, we've got 2x plus 4 equals 12 and 2x minus 4 equals 12. If that's the case, and these are minus tiles, that would mean that it's 2x marker sign. Minus 4 equals, we got 12 red positive tiles. I'll write that in red. 12. Okay, so if we take a look at our options, we only have one option that represents this equation, which is B, 2x minus 4 equals 12. Okay, next question. You have an example of an equation that's been solved by somebody, and it's asking you to basically check that equation to see that x equals 3. Okay? So the equation, it says Mark is checking to see if n equals 3, sorry I said x, if n equals 3 is a solution to the equation 9 equals 5n minus 6. Okay? Oops. Now Mark's checking to see if 3 is the answer. This is what Mark has done. Mark has substituted in for n, which is 3. And this is what he did here. Okay, he then added the 5 and the 3 together. He ended up with 8 minus 6. And then his answer said that 9 does not equal 2, meaning that both sides of the equations are the equation is not balanced, and that n does not equal 3. Now your task is to take a look. Since Mark concludes that the two sides are not equal, 3 is not a solution to the equation. Is Mark correct? Explain why or why not. Now the best way to do this is to check the work yourself. You guys know how to show proof of work now. We've done that many times. So take the time to check the question yourself. Okay, it was 9 equals 5n minus 6. And we're checking to see if n equals 3. Okay, so first of all, the one thing we need to notice here is that the letter is right next to the number in the first 5n there, which does not mean addition, it means multiplication. There is no addition sign there. If it's addition, you'll see an addition sign. If it's subtraction, you'll see a subtraction sign. If it's division, you'll see what looks like a fraction, so there's a line dividing the top, whether it's a variable or a number, from the bottom variable or number, so that's division. The only other option you have is when it's right next to each other, which is multiplication. So let's start plugging it in and see what happens. Okay, so we end up with 9 equals 5 times 3 subtract 6. We need to do the multiplication first when checking our proof. It's opposite when solving an equation. You want to get rid of the one that's not attached to the variable, but when you're doing your proof, you want to follow the order of operations: BEDMAS, brackets, exponents, division, multiplication, addition, then subtraction, in that order. So we need to do multiplication first because it's the first thing that comes up in BEDMAS for us. And 5 times 3 is 15. And we still have a subtract 6 there. So we've done the one step. Now we end up with 15 subtract 6. And 15 subtract 6 is 9. Okay? So, explain why Mark is either correct or incorrect. So first thing, when you saw in his example, he did not multiply the 5 and the 3, so that automatically makes him incorrect. He has to use multiplication to solve those two, and if he had done that, he would find that in the answer both sides are equal, and n does in fact equal 3. So that is why Mark is wrong, because he did addition instead of multiplication. Okay. The next section is solving equations. Okay, I'll run through these. Make sure when you're doing your assessment, your test, your unit test, make sure you're reading the instructions closely. For example, this one says solve each question, show all of your steps, making sure you're showing all of your work, and can you prove that your answers are correct, which means it's asking you for a proof as well, okay? So our first one here is 7m equals 42. Okay, 7m equals 42. The first step, I'm going to use a different marker because this one's dying. The first step is to rewrite the equation, because you want the equation, the initial equation that's on the test or on your sheet, whatever it may be, you want it in its original form so that you can always look back and refer back to it without it having a bunch of writing on it. So we're going to rewrite. And then we need to ask ourselves, how do we get the variable by itself? Because remember, the goal is to always get the variable by itself so that you can figure out what the variable equals. So again, when we've got a letter right next to a number, that signifies multiplication. And the opposite is how we get rid of that. So in order to get rid of it, we need to divide. So to get rid of the 7, we're going to divide by 7. Cancels out. What you do to one side, you do to the other. Divide by 7. Okay, 42 divided by 7 equals 6. Okay, now if we're checking our proof, we just need to take that amount for that variable, substitute it into the equation, and start solving. Rewrite the equation for your proof. And substitute in. So we know that now that m equals 6, or at least that's what we believe to be true. So we take this m out and put a 6 in its place. Oops, okay, and 7 times 6 is in fact 42, which means we got 42 on both sides of the equal sign, meaning our equation is balanced and that we got the correct answer. Okay, so that is how you check your proof. Okay. Next question. A plus 11 equals 17. Rewrite the question before attempting any solving. And we know that in order to get A by itself, we need to get rid of that plus 11. And the opposite of addition is subtraction. So we're going to subtract 11. Cancels those out. Again, what you do to one side, you do to the other. Subtract 11. We end up with A equals 6. Okay, and for our proof, we just substitute in for A. Now we know that A is 6. We take the A out, we put a 6 in its place. The question becomes 6 plus 11, which is 17, meaning you have 17 on both sides, and you've got a balanced equation. Okay, C over 6 equals 3 is the next question. Okay, now we need to rewrite before solving. Okay, now as I was saying before, with addition, you see the addition sign. With subtraction, you see the subtraction sign. When it's division, you have a line dividing the top value from the bottom value. It looks like a fraction. So in order to solve that, if it's division, we need to use multiplication. So to get rid of this 6 here, we're going to multiply by 6. You can just write a 6 beside that 6 in brackets to signify that. Remember, we don't use multiplication signs in this because we can often confuse them as variables. Those cancel each other out. Do the same to the other side. 3 times 6 is 18. C equals 18. Okay, now we do our proof. Substitute in 18 for C, becomes 18 divided by 6, and 6 goes into 18 3 times, which means you have 3 on both sides of the equations, meaning you have the correct answer for your variable. Okay. D, 19 equals x plus 6. Now I remember when we did this in class, hold on, I'll rewrite that real quick. We had some questions because the total was on the opposite side of the equal sign. That does not change the steps that you follow to solve these questions. You still need to get the variable by itself, and you still need to do the same to both sides in order to keep it balanced. So if we take a look, we've got an x plus 6 equals 19. So we want to get rid of that plus 6 by subtracting 6. Cancels out. We can subtract 6 from that side. Okay. 19 subtract 6 is, keep your variable on the same side it started on. 13 equals x. Okay? And again, our proof. Okay? 19 equals x plus 6. Replace the x with what x equals, because you now have calculated that. So it becomes 19 equals 13 plus 6, and 13 plus 6 does equal 19. So you've got 19 on both sides of the equal sign, meaning that you have a balanced equation and you found the correct answer for your variable. Okay. One more to go here for the one step. Now again, these are all obviously one-step equations because you only have to do one thing to calculate for that variable. There's only one operation you have to do. There's only one number you have to get rid of. So that would be a one-step equation. Okay? K subtract 6 equals 8. I'll rewrite it. Now, we've got to subtract 6 there. The opposite of subtraction is addition. So in order to get rid of this 6, we need to add 6. Cross them out to show that they've canceled out, and do the same to the other side. And 8 plus 6 equals 14. Okay? Now we check our proof. Rewrite the equation. Okay, we know now, or at least we think we know now, that k equals 14. So we take the k out, put 14 in its place. Question becomes 14 minus 6 equals 8, and 14 minus 6 is in fact 8. So you've got 8 on both sides of the equation, or the equal sign, I'm sorry, meaning the equation is balanced and that you've got the right answer for your variable. Okay? On the last page here, we start off with 3 two-step equations. Okay, it says solve each equation and show how you can check your answer. So again, making sure you're reading those instructions. This one's a little more obvious because it has a box for proof on the side, but you want to make sure you're reading those closely so that you don't miss anything. And remember, the rule when you're finished your test, check it over 3 times before handing it in, just to make sure that you haven't made any calculation errors and that you've got all your work shown. Okay? All right, so the first one here is 4x plus 11 equals 27. Rewrite it. Okay. Now, right away, we should be able to tell this is a two-step equation, sorry, because there's 2 separate numbers we have to get rid of to get the variable by itself. So right away, that shows us we should have 2 steps here, and those 2 steps need to be done separately, ensuring that you're showing all your work. Now, when we solve a 2-step equation, we get rid of the number not attached to the variable first, and in this case, that's the plus 11. Okay, now to get rid of a plus 11, we subtract 11. Cancels out. What you do to one side, you do to the other. Okay, so we end up with 4x equals 27, subtract 11. Okay, this 4x is still left, so we're going to bring that down because that's our second step. 27 subtract 11. Okay, 27 subtract 10 would be 17, so it's only one lower than that. That would be 16. Okay, now you're left with what is now a one-step equation because you've taken care of the first step already. We're left with 4x equals 16. To get rid of the 4 next to the x, because it's multiplication, we use the opposite operation, which is division. Divide by 4, cancels out. Divide by 4 on the opposite side. You end up with 16 divided by 4, okay? And 4 goes into 16 4 times. So x equals 4. Okay? Try and squeeze my proof in over here. Well, I'll do it in another color so it's easier to see. Okay. Proof 4x plus 11 equals 27 is the equation that we're working with. We now know, or we think we know at least, that x equals 4. So we're going to take the x out and put 4 in its place. Okay? Now, again, it's a two-step equation, which means your proof needs to be solved in 2 separate steps as well. But now, because we're solving it, because we know the variable, we need to walk through it using BEDMAS. So we need to do the multiplication first in our proof. 4 times 4, 16. Then we end up with 16 plus 11 equals 27, and 16 plus 11 does in fact equal 27. Meaning, you got the right answer for your variable in the question. Okay? Notice how the work is vertical. That's how your work should be, is vertical. Write the equation, rewrite it, and you can start solving here. Okay? Write what you have left, and then your variable total at the bottom. Okay? So it needs to be solved vertically, and you need to show both steps. And then same thing with your proof. Shown vertically, substitute in, show you the 2 separate calculations that you do to check your proof. Okay. B for the 2 steps is 12 equals 7 plus 5x. Oops, so I'll mark it. 7 plus 5x. Okay, rewrite. All right, so again, we have one where the equal sign, or the total is on the other side of the equal sign, but that does not change our steps. We've got a plus 7 here, so to get rid of plus 7, we subtract 7. Do the same to this side, subtract 7. Okay, now we're left with 5x we can bring down here. And 5x equals 12 subtract 7, and 12 subtract 7 is 5. Okay? Get rid of the 5. This is multiplication, so we need to get rid of that 5 with the x, and in order to do that we divide. It's the opposite of multiplication. Do the same to the other side. 5 goes into 5 one time, so 1 equals x. Okay? Try and squeeze my proof in here. Okay, we know now that x equals 1, so we can replace the x with 1. Becomes 12 equals 7 plus 5 times 1. Okay, 5 times 1, we do the multiplication first, is 5. You end up with 12 equals 7 plus 5, and 7 plus 5 does in fact equal 12. So, that tells you that you got the right answer for your variable x equaling 1. Okay? All right. getting close to 30 minutes here. I'm going to try and get through this relatively quickly here for you. Next one we have is 6n plus 5 equals 47. Terrible noise. Okay, that marker's not in. All right, two numbers to get rid of, two-step equation. Need to get rid of the one not attached to the variable first, and in this question that would be the plus 5. To get rid of a plus 5, we do the opposite, which is subtract 5. Cross them out so that you know you've done the work. Do the same to the other side. You're left with 6n equals 47 minus 5. 47 minus 5 is 42. Okay, so we've done our first step. Now we have to do our second step. And in order to get rid of the 6, because it's right next to the variable signifying multiplication, we do the opposite, which is division to get rid of it. So, divide by 6. Divide by 6. Question becomes 42 divided by 6, and that equals 7. So n equals 7. Okay. Quick proof here. Rewrite the equation. 6n plus 5 equals 47. Okay. Again, we know at this point that n equals 7, or at least we think we do, so we need to check to find out if we're right. Replace the n with a 7. Becomes 6 times 7 plus 5 equals 47. 6 times 7 is 42. You end up with 42 plus 5 equals 47, and 42 plus 5 does in fact equal 47, so you got 47 on both sides, meaning that you have the correct total for your variable n. Alright. I keep feeling like I have to say any questions, but I guess that doesn't work this way. If you have any questions, by all means, feel free to contact me through Shobi, through the student teacher communication folder. All right, 2 more sections to go here. Okay, the next section asks you, says write an algebraic expression or equation for each word statement using a variable of your choice. So you can choose the letter you want to use, anything from A to Z. Read the sentence stem carefully. You think a couple things you're looking for. You're looking for a total, because then you know if it's a total, it's an equation, okay? But let's take a look at the first one. A, 5 more than a number is 11. So that one there tells me, first of all, the word more is indicating addition. 5 more than a number, okay? If I have a group of apples and I have 5 more, that means I'm adding to that group of apples. So 5 more than a number is 11. We're going to represent a number with a variable. You can represent it with whatever you choose. I'm just going to use x. Okay, so we got our variable, and we need to increase it by 5, and it says is 11. 5 more than a variable is 11. Okay, so that would be an equation because it has a total. The next one, B, says 3 times a number less 8. So we know right away the unknown, the number, we're multiplying that by 3. So 3 times a number. Less 8. Now less, if you're having less, or if you had a certain number of apples again, for example, now you're less 8, that means you've taken away or subtracted. So subtract 8. And it doesn't say that it is anything, it doesn't tell you totals, anything, so there's no equal sign here, which makes this an expression. C, 8 more than 2 times a number. Okay, so a number representing the variable, we need to multiply it by 2. And again, more, referring to addition, 8 more, right? If you got your allowance and now your parents give you $8 more, they're adding to that. 8 more than 2 times the number. And there is no equals or is or anything like that, so this one does not have a total. It is also an expression. Okay? And the last one here is 6 times a number less 3 equals 9. 6 times a number less 3 equals 9. So right away I know this is an equation because we have an equals. Okay? 6 times a number, well, pretty straightforward. We've got to multiply 6 by the variable. And then less 3, less again meaning subtract, equals 9. Okay, so that last one there would be an equation as well. If you want to try and solve those equations, by all means, for extra practice, feel free. Okay, but this one's just asking you to write the sentence statement to represent it. Or sorry, not the sentence statement, the equation or expression to match the sentence statement. Okay, and the last question. It says, draw a picture to represent the equation 2x minus 3 equals 5. I'm going to write that up here first. 2x minus 3 equals 5. Okay, I'm going to draw my scale. Remember, that triangle can represent your equal sign. Okay, now we represent the x value with long green tiles. Okay, you can, for plus and minus or positives and negatives, you can just represent those with tiles, and you can put a positive or a negative sign inside them to signify which one they represent. Okay, so if we take a look at the question, you need to ask yourself, okay, well, how many x's do we have here? Well, if I take x and I multiply it by 2, that means we're going to have 2 x's. Doesn't matter if you write them horizontally or vertically. Okay, so we've got our 2 x's now. Now we've got to subtract 3 here as well. Okay, subtract 3. I'll do those in blue. Okay, 2x subtract 3, and it equals a positive 5. So, use 5 red ones here. All right, so that is a picture to represent that equation, but just because we've also reviewed this in class as well, I'm going to show you again, I'm just going to review how to solve a pictorial equation using pictures as well. So again, just like when we solved a two-step equation, we need to get rid of the number that's not attached first. We've got 3 negatives over here, and the only way to get rid of 3 negatives is by canceling them out with 3 positives. Okay, cancels out, cancels out, cancels out. What you do to one side, you do to the other, so we're going to add 3 positives over here. Now, if we were adding 3 negatives, they would cancel out some of these positives, but because they're also positives, they just combine to it. So currently now we're left with 2x equals 1, 2, 3, 4, 5, 6, 7, 8. Okay, get rid of the 2x, you divide by 2. You can just show divide by 2 underneath. Okay, that's going to cancel out one of those. Divide by 2 on this side, and if you count, there's 8 of them. So if I'm cutting those in half, I'm going to end up canceling out 4 of them, leaving me with my answer, x equals 4. Okay, if we take a look at it, 2 times 4, right, is 8. And if we subtract 3 from 8, we end up with 5, which means both sides are balanced, and you've got the right answer. All right, that is your review of the test. I'm going to post both your science and your math tests for Thursday this week. I believe Friday is an in-service for you guys, so don't worry about doing them on Friday. If you want to do them Thursday, feel free. We are going by the honor code here, meaning that you are doing these without notes, or help of the internet or anything like that. If you don't understand a question, you would like your parents to explain it to you so that you understand what you need to do, that is fine, but they shouldn't be giving you the answers. So math and science will be posted on Thursday. Feel free if you want to do them this week, that's fine, but I'm expecting them to be studied for and completed by next Wednesday, I think would be a good timeline. That should give some people, if they're still cleaning up anything on their projects this week, to get some study time in prior to doing the assessments. If you have any questions regarding when you can do your assessment, or if you are having trouble keeping up and you need a little bit extra time, please just contact me, let me know. Again, I'm very flexible with these timelines within reason. We got to try and all sort of stay on the same page as best we can. But I mean, if we need a few extra days here and there, I can make that happen if that's the case. So just make sure you stay in contact with me. Make sure you keep me in the loop as far as what's going on with you. That's it for today. Sorry the video is a little bit longer than I wanted it to be, but this will be posted today and you can review it so that you feel confident that you're ready for this assessment. All right? Hope you guys are all healthy and happy. Keep safe. I'll talk to you soon. And I will let you know when I've got this Microsoft Teams thing figured out and we've been given the go-ahead to use it. Okay, thank you. Have a good day.